Okay, so let's see question number 8 from October 2023 P3 paper. So question number 8 is basically from trigonometry. It is combinedly from chapter number 3 and 4 of your P3 book. So let's see what they're asking in question number 8. First question A. Prove that 2 cos x squared 2 theta times 1 minus cos 2 theta equals to 1 plus tan squared theta. So we need to show that the left hand side is equal to the right hand side. Okay, so for the first question, part A, at first consider the left hand side. What's the left hand side there? 2 cos x squared 2 theta times 1 minus cos 2 theta. Okay, so definitely we need to simplify this left hand side to get the right hand side. So when you simplify, keep in mind that if you see the equation on the right hand side, the term on the right hand side, it is 1 plus tan squared theta. But on the left hand side we have all the double angles 2 theta 2 theta. So we need to simplify them to single theta, that is only we need to convert the 2 thetas into theta only. Okay, so 2 cos x square theta. So we will use the formulas for double angle that we know from trigonometry. So we will definitely use them, but we will use them part by part. So at first, let's simplify the bracket. In the bracket, what we have? 2 cos x square 2 theta. Keep it as it is. We will simplify it later on. Let's simplify the part within the bracket. So cos 2 theta. Cos 2 theta can be written as cos square theta minus sin square theta. So cos square theta minus sin square theta, but it would be minus, but before cos 2 theta there was a negative, so that would be what? Plus sin squared theta. Okay, next what we need to do? Next we will simplify. We can further simplify what? The bracket. How we can simplify the bracket? Cos square theta can be written as 1 minus sin squared theta. So 2 cos x squared 2 theta cos x squared 2 theta times 1 minus cos squared theta can be written as 1 minus sin squared theta. So minus, since there was a negative sign before cos squared theta, so that would make it positive. So positive sin squared theta plus sin squared theta, this will be plus 2 sin squared theta. Okay, next what we can do? Cos x squared 2 theta. Now we can simplify. We can start simplifying the cos x squared 2 theta. So cos x squared 2 theta can be written as 2 over sin squared 2 theta times what? 1 minus 1 cancels out, so you'll get 2 sin squared theta. Okay, next what we need to do? Simplify sin squared 2 theta. Sin squared 2 theta can be written as what? 2 over 4 sin squared theta cos squared theta, sin squared theta cos squared theta. So cos squared theta times what? 2 sin squared theta was there, so multiply as it was. Then what we can do? Look, 2 times 2, this is 4. So this 4 and that 4 on the denominator will cancel out, and sin squared theta from the top will cancel out the sin squared theta at the bottom. So we can write 1 over cos squared theta just. So 1 over cos squared theta can be written as sec squared theta, but we will not write this. We will do what? One, you can write this, both approach will be fine. The one I was talking about, this was writing sin squared theta plus cos squared theta, because sin squared theta plus cos squared theta is what? 1. So we can write it like this, cos squared theta. So what we can do? Sin squared theta over cos squared theta, this is what? Tan squared theta, and what? Cos squared theta over cos squared theta, this is what? Just plus 1. That's what they wanted in the right hand side. Or the other thing you could do here, if you would write 1 over cos squared theta, you can write sec squared theta. So sec squared theta can be written as what? From trigonometric identities, we know that sec squared theta minus tan squared theta, this is 1. So sec squared theta can be written as what? 1 plus tan square theta. Both ways will work, no problem. Same thing. So that's what we got, the right hand side. Right hand side. Okay. So in this type of questions, like from trigonometrical simplification, most of the students get confused, like how to approach it or how to do the workings. So keep in mind, look at the right hand side at first, like what they wanted on the right hand side, what they wanted as proof. Since they wanted tan square just theta there, so that's why my first aim was to simplify the double angles to the singular angles, and that's how I approached the answer. So when you do the workings in this type of questions, at first keep your eyes on the right hand side. Okay, that what the question has asked to prove, keep this in mind. Okay, so for part B, let's see the part B, what they have asked in part B. Hence solve for x greater than 0 less than 360, where x is not a multiple of 90. It means x is not a multiple of 90 degree, where n element integers, okay, natural numbers. The equation, we need to solve this equation. So already we have simplified this equation in the previous question. Like this equation can be written as what, 1 plus tan square theta. They considered, in place of theta they considered x, so we will write what, part B, in place of left hand side for part B we will write 1 plus tan squared x, tan squared x. It is equals to what? It is equals to 4 plus 3 sec x. So this is not a proof, this is basically solving an equation. So let's simplify it at first to a single trigonometric ratio. So that can be written as what? Tan squared x. So tan squared x can be written as what? We know that sec squared x minus tan squared x, this is 1. So tan squared x can be written as what? Sec squared x minus 1. So 1 plus sec square x minus 1 equals to 4 plus 3 sec x. Okay, so what we got, 1 minus 1 cancels out, so you'll get sec square x. Take this 3 sec x to the left, so you'll get 3 sec x. Okay, take this 4, take this 4 to the left, what you will get, negative 4 equals to 0. Now we got an equation in terms of only sec x. So what we can do, we can use we can do middle term factorization, because sec square x minus what, minus at first consider plus sec x minus 4 sec x minus 4 equals 0. So what we can do, we can take sec x common from there, sec x common. If you take sec x common, what you will get, sec x plus 1, and from there you can take negative 4 common. If you take negative 4 common, you will get either 0. So either sec x equals to 4 or sec x equals to what, sec x equals to negative 1. So what we can do now, we know that the inverse, not the inverse, the reciprocal of cos x is what, sec x. So we can inverse it, we can just reverse it to get cos x equals to 1 over 4, and again, or cos x equals to negative 1. So if you see the equation, go back to the equation, if you see that they have given a condition that x is not equal to multiple of 90 degree. So that means for cos x equals to negative 1, we know that cos 0 degree is 1, 90 is 0, 180 is minus 1. So pi, 180 degree. 180 degree is a multiple of 90 degree, so it's not acceptable. Again, cos 180 degree is minus 1, 270 is 1, 270 is 0, 360 is again 1. So for cos x equals to -1, we won't get any possible values for x. Only we will get for cos x equals to 1/4. So we will get x equals to what? Cos inverse 1/4 is what? Cos inverse 1/4. What we will get? It's 75.5 degree, 75.5 degree, 75.5 degree. Use the cast diagram. So 75.5 degree is the what? Is the principal value we got in the first quadrant. So use this 75.5 degree to get another angle in which quadrant? CAST. So we will get another angle at which, where? C, cos theta is positive. In which quadrant next? Fourth quadrant, between 0 to 360 degree. So on the fourth quadrant we will get another possible value for x. So this is what? 360 minus 75.5. So 360 minus 75.5 degree. This is 284.5 degrees. These are the two possible values for x within the given range of x to 1 decimal place. Keep it to 1 decimal place. That's the answer. That's all about question number 8 from October 2023 P3 paper.